Hey everyone, welcome to class today. We're going to go over bases and heights of parallelograms. And in doing so, we are going to look at the area of the parallelograms some more and do it a little differently than we've been doing, but using the same concepts just to get us there. So this is a parallelogram, and we've got two students, Elena and Tyler, and they were finding the area of this parallelogram. So let's see how they did that. So Elena, she did it. Now you remember we talked about last week, we've been talking about for a little while, decomposing the shapes and rearranging them to make shapes that are a little easier to find the area. So that's what they've basically done. So you can see Elena did this. She cut this right triangle out, and then she moved it over to the right to make this rectangle. Let me show you that. So she cut this right triangle out, and you can see it right here, and then she moved it over to make a rectangle, which makes this a lot easier to find the area. And then she could just count, if she wanted to, the number of squares within that parallelogram. So let's look and see how Tyler did it. Well, he also decomposed or cut this parallelogram into a couple shapes, and then took this trapezoid. Now we're used to working with rectangles when we're decomposing, but Tyler decided to cut it and make a trapezoid. But he did the same thing. He decomposed it and then rearranged it and just moved it to the right side to make the rectangle that we saw Elena working with. So again, we can decompose and rearrange into a rectangle to make it a little easier to find the area. But let's think about it differently. How many sides do we have here? We've got, or how long is one of these sides on the parallelogram? Because remember, opposite sides of a parallelogram are the same length. So this side and this side would be the same length, and then this side and this side would be the same length. So let's take a look at that. So this side would be, well, let me erase that so we can see it a little better. All right. So this side we've got 1, 2, 3, 4, 5, 6, 7. So that is 7. And on this side we've got 1, 2, 3, 4, 5, and 6. Whoop. Okay, we've got 6 right here. So if this rectangle is the exact same, then this side is 7 and this side is 6 also. So what does all that mean? Where am I going with this? So if you can see the sides of this parallelogram, the measurements that we see, they have special names. So the length of one side of the parallelogram, which is also the length of one side of that rectangle that we made, it's called a base. So this side right here called the base. And the length of the vertical cut segment, what does that mean? The cut segment is where we cut. See the little scissors here? This is the segment that we cut out. So the vertical length of that, which is also the length of the vertical side of the rectangle, that's called the height. That corresponds to the base. So again, we've got, see this black circle here, we've got the base. This is a B. And then this segment that we cut, which we can see over here, that's called the height. So if we look at this rectangle at the bottom, again, we've got a base here. And then remember, Tyler cut this section out and moved that trapezoid. So the section he cut is the height. So we've got the base down here, and then the height here, which is the vertical line that Tyler cut out. So let's go to the next one. Let's see how they did that and kind of walk through it so you can see it a little bit better. So this is the one that Tyler did. And you'll see, let me go back. We've got the base down here at the bottom. He chose this bottom segment as the base. And then he cut the trapezoid out. And we can see the trapezoid right here. But then he moved the trapezoid or rearranged it so we could make a rectangle. And then remember, we said this side was 7 and this side was 6. So let's look at that again. So he chose the base down here. This line here, he chose that as his base. Then he cut a vertical line segment out to make a trapezoid. And then he moved that trapezoid or rearranged it to make a rectangle so he could find the area. So let's look at how Elena did that. Now she did the same exact thing. She chose this bottom line segment as the base. So then she cut a vertical line segment from the base to make the triangle you see there. And then she moved that triangle to the right side or rearranged it so she could make a rectangle. It makes it a little easier to find the area. So let's look at that one more time. She chose this side as the base down here at the bottom, and then she cut a vertical line segment to create a triangle. And then she moved that triangle or rearranged it to make a rectangle. So let's go back to our PowerPoint. So let's take a look at a few examples. All right, we're going to identify a base and a corresponding height and then record their lengths in the table. And then we're going to find the area of the parallelogram and record it in the last column of the table. So let's look at A. So let's choose this bottom segment as our base. Okay. Choose this as our base. And we'll choose, since this is already a rectangle, we don't have to cut anything out, but we can still find the height. So the height would be, and remember I forgot to mention, when you're cutting a vertical line segment from the base, it always has to be at a right angle. So what is a right angle? that means it's a 90-degree angle. What does a 90-degree angle look like? It looks like the letter L. So you see this here? That is a 90-degree angle, or it's supposed to be. So when we cut a vertical line segment at a 90-degree angle from this base, we get the height here. So now let's count. The base line segment is equal to 1, 2, 3, and 4. So down here, we're going to write the number 4. And then the height in units is 1, 2, 3, 4, 5, and 6. All right. So what is the area? And we need to count those squares in there. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So that would be our area in square units. Okay, so let's look at B. All right, so we will choose this line segment as our base. So now what do we do? Remember we talked about cutting a vertical line segment at a right angle. So let's cut it right here. And then you see we've got the triangle here. Go back to our base. And then cut this out again. And then we can move this triangle over here. So that gives us a nice, simple rectangle that you see in blue that we can now find the area. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we got the area is 15. Now I need to go back. I apologize. Let's count the base in units. 1, 2, 3, 4, and 5. That's supposed to be a 5. And then we've got the height, 1, 2, and 3. Okay. So what do we have here? If you notice, let me erase these lines so it's not confusing. If you notice, the area of A is 24, and we got that by counting the squares. But if we look at the base, we know that it's 4, and then we look at the height, and we know that it's 6. What is 6? What is 4 times 6? 4 times 6. Now we know what that is. It's 24. All right, what about B here? We said that the base was 5. 1, 2, 3, 4, 5. And then we found the height, 1, 2, and 3. So, and we know that the area is 15. Well, what is 5 times 3? Well, we know that that's 15. So what can we do with all of that information? Well, that gives us a simpler way to find the area. Instead of having to count all of these squares that are inside of this shape, we can multiply the base times the height. And that cuts out a lot of time that we spend counting those squares inside that shape. So let's write that out. We've got the base times the height. So remember that base times height when we're finding the area of a parallelogram. All right, so in this lesson, we've identified a base and a corresponding height in a parallelogram, and then wrote an algebraic expression. Remember, we wrote that algebraic expression for finding the area of any parallelogram. And that expression is base times height. So how do you decide the base of a parallelogram? Well, you can choose any segment, any line segment that you want. So let's go back to the very beginning. If we wanted to find the base of this parallelogram, we could choose any of these lines that we wanted. I usually like going for the line that's in the bottom, just because it makes it easier for me, but that's up to you. So once we've chosen a base, how can we identify a height that corresponds to it? Well, let's go back. So what did we talk about? Once we find the base, then we can cut a vertical line segment at a 90-degree angle to make a new shape, and then we just move that shape or rearrange it to make that rectangle. So again, how do we decide the base? We just pick one of those line segments. It can be any one of the two parallel line segments on either side. You can pick any of them. Then once we've chosen that base, how do we identify a height? Well, we cut a vertical line segment at a 90-degree angle from that base, and that will give us a new shape that we can then rearrange to come up with a rectangle that makes it easier to find the area. So then what is the relationship between the base and the height of a parallelogram and its area? Well, if you recall from previous grades, when you multiply two things together, the answer that you get is called the product. So when we multiply the base times the height, the area, or the answer that we get, which is the area, will be the product of the base times height. So big takeaway, remember, find the base, just pick one of those line segments, and then once we've picked that line segment, we cut or draw a vertical line at a right angle to create a new shape. Then we rearrange that shape to create a rectangle, and then we multiply base times height to get the area. So this here, I will post this as an exit slip later this afternoon, and you can work on that and turn that in for me. If you have any questions, please feel free to reach out to me either in Google Classroom or via email, and I will get back to you as quickly as I can. But again, I will post this for you in an exit slip, and then we will see you all on Wednesday. Have a great day, and we'll see you then.